Detecting IP anomaly. In this lesson, we will explore how to detect a user that seems to connect from many different geographical locations simultaneously. A user connecting from many locations, often referred to as impossible travel, could potentially mean account sharing or credential stuffing or botnets using stolen credentials or even automated fraud. We will build on top of the same stack that we set up in the previous lessons, which is ingesting access logs from a local Nginx server. RioDB will analyze the access log from Nginx in real time, and when threats are detected, it will immediately invoke remediation to flag the user for a CAPTCHA challenge to prove they are human. In a previous lesson, we covered shipping Nginx access logs to RioDB. The same can be achieved for other types of logs, such as access logs from an Apache Tomcat application server or firewall traffic logs. Our first step today will be to create a window that counts distinct IP addresses that a user connects from. We will call this window Locations by User 30S. As the name suggests, this window will look at all logs with no conditional filter, and it will count how many distinct remote addresses a user appears to connect from during the range of 30 seconds. We are using the partition clause here because we don't want to count the total distinct addresses for all users globally. We want RioDB to count for each individual user. Each user gets their own count of distinct addresses. In a nutshell, at any given moment, this window can tell us how many distinct addresses each user has connected from during the previous 30 seconds. Next, we will create a query that selects the user field from the log records, and we will also include the window locations by user 30S. Our condition is to search for times when a user has connected from more than 5 distinct addresses during the past 30 seconds. This is not a recommended formula, but an example just to illustrate how RioDB works. Comparing to traditional SQL, notice that the condition clause is when instead of where, which reminds us developers that this query will run continuously and indefinitely, thousands or even 1,000,000 times per second. And it will trigger the output mechanism when the conditions are met. In summary, if any user connects from more than 5 IP addresses within 30 seconds, this query will catch it. Once conditions are met and the threat is detected, RioDB will then trigger the output. In this case, I have the output set to use the HTTP plugin. In parentheses, we specify the configuration details pertaining to the plugin. I'm instructing RioDB to invoke the URL of an API that will flag the user for a CAPTCHA challenge. Are you human? In this example, we're assuming that the application server is a website, and the application has methods for flagging user profiles to be met with a one-time CAPTCHA challenge. Summarizing the whole thing so far, user connects from more than 5 different IP addresses within a 30-second range. RioDB detects it and notifies a service to flag the user profile to receive a CAPTCHA challenge. Assuming the require CAPTCHA API takes application JSON payload, we will format the user field and value using the JSON formatter. Finally, the sleep clause. In the case of an automated cyber attack, this username could appear in thousands of requests per second. When the query catches it, we should avoid invoking the require CAPTCHA API thousands of times repeatedly. So the sleep clause acts like a cool-off period. Once the query triggers the output mechanism for a username, it will ignore that username for at least 60 seconds. Now that everything is set, let's hit send. On the right, we get a response from RioDB, acknowledging that both the window and the query have been created. The scanning for the IP anomaly threat is now in effect. Again, the require CAPTCHA function used here is just an example. In your real-world use case, you might opt for blocking IPs completely or rate limit them. As mentioned in another episode, a single instance of RioDB can be used to receive logs from many endpoints, from multiple devices in multiple regions, in order to analyze the full traffic from one central place. Thank you for watching, and stay tuned for more examples in this series.